Hi everybody, and welcome to this revision video on the sleep-wake circadian rhythm as part of the psychological health and well-being topic for stage 2 psychology. So let's get started. So sleep is extremely important for mental health. So we're going to first talk in this video about why it's important and the general basics of sleep and the sleep-wake cycle, and then we're going to go into the biological and chemical processes that fuel this circadian rhythm. So getting enough sleep is very important to ensure positive mental health. Sleep deprivation has a very negative effect on our psychological state, and people with existing mental health disorders are more likely to have insomnia or other sleep disorders. So again, it's a bidirectional relationship where if someone is very sleep deprived or has a sleep disorder, they're more likely to develop a mental health disorder, and people with a mental health disorder are far more likely to have insomnia or a sleep disorder. So again, it's a bidirectional relationship. It goes both ways. About 40 to 50% of people with insomnia, which is the inability to get to sleep and or stay asleep, also have a mental health disorder. So insomnia is one of the main symptoms or one of the main side effects of several mental health disorders that we have discussed already in this topic. In another video that I will do, I will go into insomnia in a lot more detail. That video will be on sleep disorders. So if you are not getting enough sleep, though the recommended amount of 8 to 10 hours of sleep per night as Year 12 students, and think you can survive on 7 hours or less as a teenager, it is time to consider the research that suggests that sleeping is essential. So you all have heard me nag you about it before. You should be getting at least 9 hours, or 10.5 is ideal. I realize that's unrealistic. All right, so at least 9 hours. So let's actually go through now how it works. So, humans have what are called circadian rhythms. We actually have several of these. It's not just the sleep-wake cycle. We have several circadian rhythms. There's one for temperature, there's one for growth hormone secretion, there's one for digestion, there's one for pain tolerance. We have several of these, but the one that we focus on in this topic is the sleep-wake circadian rhythm, or sleep-wake cycle, as it's often nicknamed. So our level of awareness as humans, or our level of alertness as humans, is at its lowest in the early hours of the morning between 2 and 4 a.m. and then peak in the late afternoon between 4 and 6 p.m. Also in the afternoons, we tend to have a lull or a drop in our level of alertness between 2 and 3 or 2 and 4 p.m. So that's when we feel especially sleepy and when people are more typically likely to nap. And there is a theory as to why that is that I'm going to talk about in another video, which is on the evolutionary theory of sleep. So what this means is that our level of alertness will increase and decrease depending on what time of day it is. However, there are other things or other factors that can alter our level of alertness and our sleep-wake cycle. These collectively are known as Zeitgebers. So in other words, they're variables that can affect our sleep-wake cycle. And there are lots of these. So that might include sleep debt. So obviously the difference between how much sleep we should get versus how much we do get if it's a deficit. Sunlight, shift work, interest level, even regular meal times, as I've said down here, can be a Zeitgeber or a variable that affects our sleep-wake cycle. But it is important to note at this point that us humans, our main Zeitgeber is sunlight or light in general, for reasons that will become apparent as we go through this video. So all circadian rhythms are controlled by areas in the brain, and the sleep-wake circadian rhythm is no different. So just like I just said, our most obvious Zeitgeber is daylight. So when daylight hits our eyes, cells in our retinas, which is at the back of the eye, signal to our brain what we should be doing. So whether we should be awake or whether we should be asleep. So let's go into this in more detail. So our sleep-wake cycle or sleep-wake circadian rhythm is controlled by what's called the suprachiasmatic nucleus, or SCN. This is a small cluster of nerve cells located in the hypothalamus of the brain. So you can see here on this image, and this is in the PowerPoint as well, it is a tiny, tiny cluster here of nerve cells in the hypothalamus, roughly about the size of a pea, or even smaller in some instances. So the SCN is our biological clock that keeps track of the time of day. So it's our SCN that signals to the rest of our brain and body what we should be doing, whether we should be awake or whether we should be asleep. And light is the main external cue that syncs this clock. So it's light that our SCN detects and then adjusts our other levels or other processes in our body accordingly, whether we need to wake up or whether we need to fall asleep. So let's talk about the actual process. There are receptors in the back of our retinas, all right, which is obviously in the back of our eyes, that detect the level of light. So as we can see here in the diagram, light enters our eyes. Even if our eyes are closed, they can still detect light. Retina is obviously at the back of the eye here. The retina will send an electrical impulse or a message to our SCN as to what time of day it is and whether we need to be awake or asleep. So as I've said here, this is converted again into an electrical impulse that travels from the retina to the SCN, which responds to changes in light. And it's the SCN which sends messages to the brain and the body that help them adapt to whether it is day or night. So our SCN, we know, controls the sleep-wake cycle, but then it takes it a step further. Our SCN will then send a message to our pineal gland, all right, which is in the back of our brain. If I just go back to the diagram here, we can see the pineal gland is here. So our SCN, once it receives information from the retina, all right, whether that's light or darkness, it will then send a message to our pineal gland, and it's our pineal gland in the brain which adjusts what's called our melatonin levels. So melatonin is our natural sleep hormone that tells the body whether it should be awake or asleep. So the more melatonin we have in our system, the more sleepy we feel. So makes sense that melatonin levels are at their highest at night and are at their lowest during the day. So when we're wide awake and it's the middle of the day, our melatonin levels are low. When we're very sleepy at night, in the wee hours of the morning, our melatonin levels are at their highest. So if we are exposing our retinas to a lot of light, or they detect light, it sends a message to our SCN, which then sends a message to our pineal gland to stop the production of melatonin. So light inhibits the secretion of melatonin, which is why we shouldn't be on our phones or screens before bed, because our circadian rhythm gets confused and doesn't release the correct amount of melatonin to allow us to get good quality and quantity sleep. Okay, so that does it for this revision video, guys, on the sleep-wake circadian rhythm. In my other videos, I go through a lot more on sleep in terms of stages and hygiene and all sorts of other goodies. So if you've got any questions, let me know.